guys, welcome back to my YouTube channel. I am Karina and our today's subject is Mathematics for Engineering. And topic is definitions and examples of a particular group, Klein. To begin with, what is Klein group? It is often denoted by V4 or simply V. It is a group in abstract algebra named after the German mathematician Felix Klein. It is one of the simplest examples of a finite non-cyclic group. So the Klein group V4 is defined as a group with four elements where each element is its own inverse and the group operation is associative. The group can be represented as V4 flower brackets E, A, B, C with a closed bracket. Here E is the identity element and A, B and C are the non-identity elements. The group operation, often denoted as dot or plus, satisfy the following properties. E dot x equals x dot E equals x for all x belongs to V4, or x dot x equals E for all x belongs to V4. The operation is also associative, that is x into y into z, which is equals to x into y into z for all x comma y comma z belongs to V4. And here is the given group table. Properties. The order of V4 is 4, meaning it has 4 elements. Abelian group. The Klein group is abelian, which means that the group operation is commutative. X dot y equals y dot x for all x comma y comma belongs to 4. And the abelian condition is also that the group should be either associative and closure property. Subgroup. V4 has 4 subgroups, each of order 1 or 2. These subgroups are E, A, E, B and E, C. Isomorphism. V4 is isomorphic to the direct product of two cyclic groups of order V4, that is Z2 into Z2. Example. There are two types of representation. One is permutation representation. V4 can be represented by permutations of 4 objects where each permutation is its own inverse. For example, consider the set 1, 2, 3, 4. Here E is the identity permutation and A, B and C are the sets. The next one is matrix representation. It can also be represented by certain 2 cross 2 matrices with the entries in Z2, the fields with 2 elements. Application. The first application is symmetric and group theory. In engineering, particularly in the study of symmetry in mechanical systems and structures, the Klein group 4 can describe the symmetries of certain objects. For example, in robotics and structural engineering. Understanding the symmetries of a system can simplify the analysis of its behavior under various operations, that is rotations and deflections. Coding theory. In digital communications and error correcting codes, the Klein group is used to construct and analyze codes. The properties of V4 can help design error detection and error connection algorithms. For instance, the group structure can be employed to create linear codes with specific error handling capabilities. Finite state machines, which are fundamental in the design of digital circuits and systems, can utilize group theory for state minimization and transition analysis. The Klein group properties can aid in simplifying the state transition diagrams and optimizing the design of sequential logic circuits. Cryptography. In cryptographic algorithms, group theory, including the Klein group, plays a crucial role in developing secure communication protocols. The algebraic structure of V4 can be applied in designing cryptographic schemes that rely on group operations for encryption and decryption process. For example, coding theory application. So let us consider a simple example in coding theory where the Klein group V4 is used to construct a binary linear code. So let's define the code. Let the elements of V4 can be represented as the binary vectors. The second one is code construction. Construct a linear code C using these vectors. The code C will include the vectors and their linear combination. The third one is error detection. This code can detect single bit errors. For instance, if a transmitted code word is 1, 0, 1, 0, 1, 0, and a single bit error occurs resulting in 1, 1, 1, 1, 1, 1, the receiver can detect the error by recognizing that 1, 1, 1, 1, and 1, 1 is not a valid code word. Normal subgroups and quotient groups. In the context of larger groups, V4 often appears as a normal subgroup. For an instance, in the symmetric group S4, the Klein 4 group can be found as a normal subgroup. This helps in analyzing the structure of the group using quotient groups. Automorphism. The automorphism group of V4 denoted by aut V4 consists of all the isomorphism from V4 to itself. Since V4 is abelian and has multiple subgroups of the same order, the automorphism group is isomorphic to the symmetric group S3, which permutes the three non-identity elements A, B, and C. Advantages of Klein group 4. Simplicity and structure. The Klein 4 group is composed of four elements E, A, B, C, where E is the identity element and A, B, and C are the non-identity element. And here each non-identity element is its own inverse. The second is the abelian nature. The group is abelian, meaning the group operation is commutative, closure as well as associative also. Direct product of cyclic groups. V4 can be seen as the direct product of two cyclic groups of order Z2 into Z2. This makes it a useful example in studying direct products and their properties. Group theory applications. The Klein 4 group is often used as a simple example in group theory to illustrate concepts such as normal subgroups, quotient groups, and homomorphisms. It serves as a key example of a group that it is not cyclic but is still abelian. Symmetries and geometry. In geometry, V4 can be used to describe the symmetries of certain shapes. Example, it is a symmetry of a rectangle that is not a square. It also appears in the study of the symmetries of the tetrahedron and other polyhedra. Error detection and correction. In coding theory, the structure of V4 can be used in designing error detecting and error correcting codes. Its properties makes it useful in certain coding algorithms. Representation theory. V4 has a straightforward representation theory with each element being representable as a 2 cross 2 matrix. This simplicity aids in understanding representations of more complex groups. Applications in algebra. The Klein 4 group is used in solving polynomial equations and in understanding the structure of field extensions in Galois theory. The Klein 4 group's unique combination of simplicity, structure, and versatility makes it fundamental example in various fields of maths, including group theory, geometry, and algebra. Let's have a look on disadvantages of Klein group. Limited size and structure. The Klein 4 group is very small, consisting of only 4 elements. This limits its applicability in scenarios requiring large or more complex group structures. Lack of cyclicity. Unlike cyclic groups, V4 is not generated by a single element. This can make certain operations and applications less straightforward compared to cyclic groups where every element is a power of a single generator. Restricted symmetry descriptions. While V4 is used for describing symmetries of specific shapes like rectangle and certain polyhedra, it is not applicable to more complex or higher order symmetries. For an instance, it cannot describe the symmetries of regular polygons with more than 4 slides. Limited representation in coding theory. In coding theory, the simplicity of V4 may be a drawback when more sophisticated error detecting and correcting codes are needed. Larger groups can provide more complex structures that are beneficial for advanced coding algorithms. Finite abelian group limitations. As a finite abelian group, V4 lacks the complexity of non-abelian groups, which can have rich and more diverse applications in fields such as physics, chemistry, and cryptography. Simplistic Galois group. While V4 can be used to solve certain polynomial equations, it represents only a very basic example. More complex field extensors and polynomial equations require the set of large or more complex Galois groups. Representation theory constraints. The representation theory of V4 is quite simple. which is useful for educational purposes but limiting for more advanced studies that require the richer structure of larger groups. In applicability to certain algebraic structures, V4 cannot be used to represent or model certain algebraic structures and phenomena that require non-abelian groups or groups with higher orders. In summary, while the Klein 4 group has several educational and theoretical advantages, its simplicity and small size also means it has limited applicability in more advanced, complex, or large-scale mathematical and practical contexts. Thank you guys. Please stay tuned for more such videos. Please do like, share and subscribe.